Hello everyone, enjoying statistics and linear algebra. All these concepts are discussed. I could suggest you to watch all the previous videos. In the description of this video, the links for the previous videos are given. Today we do solve some more problems on a bivariate CDF and PDF. Here the problem is given. A bivariate PDF for the random variables x and y it is a notation for a bivariate PDF. Small f is used here. It is given as 1 divided by 1.4283 pi e to the power minus in the bracket x square minus 1.4 xy plus y square divided by 1.02, where x and y's are varying from minus infinity to plus infinity. For this, they have asked us to calculate PDFs for x and y. They are nothing but single random variable probability density functions, are also called as probability densities or a marginal densities. The next point is volume under the PDF surface 1? Are x and y independent? For the first calculation, we should know two formulas, fx of x and fy of y. Fx of x, a single random variable probability density function that can be calculated by integrating a bivariate PDF with respect to y. Similarly, single random variable probability density function of variable y that can be calculated by integrating a bivariate PDF with respect to x. Given a bivariate PDF is this one here. So need to concentrate on this equation. It should be written such that while calculating fx of x, all x terms should be taken as a constant because it is integrated with respect to y. Similarly, while calculating fy of y, this term is adjusted such that all y terms should be taken outside the integration because it is integrated with respect to x. Let us we do some arrangement to this equation using a technique called completing square. We are about to calculate here fx of x. For that reason, do some arrangement to this equation. Take 1.4, half of it is 0.7, square of 0.7 is 0.49. Here we are calculating fx of x, so that adding and subtracting 0.49 x square to this equation. As a result, 0.49 x square, 0.49 x square added and subtracted here. So everything is same here. Y square is written first, 1.4 x square, x into y plus x square. So let us make use of a minus b whole square formula. So first three terms, they are in this form. In the place of a, y, in the place of b, 0.7. So that first three terms can be written y minus 0.7 x whole square format. And these two terms, 1 minus 0.49 can be written as 0.51 x square. As a result, the given a bivariate PDF can also be written in this format if we want to calculate fx of x. Alright, so let us make use of a formula. Substitute the value of fx of x. Later, e to the power a plus b can be written as e to the power a into e to the power b. Let us divide 1.02 this first term and second term. So separate this exponential. Later, this is having an x term. This integration is with respect to y, so that it acts as a constant. Take it outside from the integration. Alright, so the remaining terms are only exponential of minus of 1 minus 0.7 x whole square divided by 1.02. it is being integrated with respect to y. So this integration can be solved using a change of variable concept. Let us substitute y minus 0.7 x whole square divided by 1.02 as u square by 2. Let us substitute. These two terminologies can be replaced by u square by 2. So taking square root on both sides, what we get here, u by root 2 equals to y minus 0.7x divided by square root of 1 minus 0 2. Alright, so we have used here a change of variable concepts so that this dy should be replaced in terms of y. For that reason, differentiating this term, differentiation of u is du divided by root 2, differentiation of y is dy, differentiation of 0.7x is 0 because it is being differentiated with respect to y. 0.7x acts as a constant, so that 0. As a result, this dy can be replaced by square root of 1.02 divided by 2 into du. This fx of x can be written as constant terms written as it is. Dy is written so that 1.02 divided by 2 under square root, and this term is replaced by u square by 2. Alright. So using the definition of a gamma function, we know gamma function varying from minus infinity to plus infinity exponential of minus u square by 2 can be replaced by a 2 phi. So we do find such terminology in the equation. You can observe here. These two are one and the same here. It is these two are one and the same. So that these terminologies can be replaced by square root of 2 pi. Alright, do the simplification here. So minus 0.51 divided by 1.02 is 0.5. That can be written as 1 by 2. Here root 2 and root 2 are cancelled. Root pi divided by pi is root pi. 1.02 divided by 1.4283 gives a value of 0.7071. 1 divided by 7071 can be replaced by 1.414. That 1.414 can be written as root 2. Already we do find here a root pi. So that fx of x is calculated here. It is exponential minus x square by 2 divided by square root of 2 pi. However, let us find fy of y. Using this formula, we have calculated fx of x. Fy of I can be calculated by integrating a bivariate PDF with respect to x. This is given. So similar to the first procedure, do some modifications to this existing equation. Again, make use of a technique of completing the square. Consider that equation. Take 1 by 4, half of it is 0.7. 0.7 square is 0.49. We are calculating fy of I, so that adding and subtracting 0.49 y square. You should understand here the difference. So 0.49 y square added and subtracted here. Using a minus b whole square formula, first three terms are in this format, so that these terms can be written as x minus 0.7 y whole square. Because of these two, it can be written as 0.51 y square. So that the given term, the given bivariate PDF can also be written in this format. Need to follow these procedures while calculating fx of x, while calculating fy of y. What are the adjustments we have done? You should take care of them. Fx of x is calculated here. Now let us recalculate fy of y. So fx of x, it can be calculated by integrating a bivariate PDF with respect to y. Here fy of y is to be calculated. Integrate this with respect to x, that is done here. We know the formula of fx of x and fy of y. And fx of a bivariate PDF is replaced here. Then again make use of e to the power a plus b as e to the power a into e to the power b. So before that, divide this 1.02, this term and this term. So here this term consists of y term, because y term, this equation is being integrated with respect to x, so that it acts as a constant. Take it outside. The remaining terms are only this one. Again make use of a change of variable. These all terms are replaced by u square by 2 and take square root on both sides, u by square root of 2, and differentiate with respect to x here, not with respect to y. It should be differentiated with respect to x. So du by root 2, that is equals to dx divided by square root of 1 by 0 to 0.7 into y is a constant. Differentiation of that is 0. So as a result, dx is equals to under square root 1.02 by 2 into du. So finally, this complete expressions can be replaced by dx is replaced by, and these two terms are replaced by minus u square by 2. And making use of a gamma function, so we do find one gamma function in the expression that can be replaced by square root of 2 pi. After simplification, this becomes 2 1 by 2, and it can be replaced by square root of 2 pi. After simplification, we do find fy of y as it is. Alright, for a given bivariate PDF, we have calculated fx of x and fy of y with a proper adjustment to this term. Is volume of the PDF curve 1? We know the property of a bivariate PDF. Volume in the bivariate PDF is always 1. To satisfy this equation, either you have to take fx of x or fy of y, integrate it over the range minus infinity to plus infinity. If it equals to 1 means these conditions will be hold good. So let us take fx of x. We have calculated this fx of x as exponential minus x square by 2 divided by root of 2 pi. Alright, let us make use of a gamma function. 1 by 2 pi is a constant, so this integration along with this exponential acts as a gamma function, so that can be replaced by square root of 2 pi. After simplification we will get 1. Because of this condition, we can say that for a given bivariate PDF, volume under the curve is 1. It can be proved using fy of y also. So 1 among 2 is sufficient. Are x and y independent? To say that a given two variables x and y are independent, this equation should be satisfied. A bivariate PDF should be equals to multiplication of individual PDFs here. A bivariate PDF is given. We have calculated fx of x and fy of y. If these two are multiplied, this is the result. 1 by square root of 2 pi into 1 by square root of 2 pi is 1 by 2 pi. So if these two are multiplied, this will be the result, but it is not equals to the given PDF. So that we can say that x and y are not dependent. They are independent each other. All right. So let us take this as assignment problem. The only change is made, instead of minus it is plus. Follow the same procedures so that you can get a proper results. For this problem, calculate fx of x and f of y. Use value under the curve is 1. Are x and y independent? Follow the same procedures and you should take care of this plus sign. Write it in assignment book. We solve the next problem. A bivariate PDF for the random variable x and y is 1 divided by 1.9079 pi exponential of minus inside the bracket x square minus 0.6 xy plus y square divided by 1.82, where x and y's are varying from minus infinity to plus infinity. Calculate r. What are the PDFs for x and y? Is value under PDF surface 1? Are x and y independent? We know formula for fx of x and fy of y. This is the given expression. We need to adjust this term such that it is helpful in the calculation of fx of x and fy of y. We have to follow the same procedures. Using technique of completing the square, consider the equation. Half of 0.6 is 0.3, square of 0.3 is 0.09. Adding and subtracting to this equation by a value 0.09 x square. Added and subtracted here. Using a minus b whole square formula, first three terms can be written in this format. Alright, so y minus 0.3 whole square plus 1 minus 0.09 can be written as 0.91 x square. So the given PDF can also be written in this format while calculating fx of x. We know this formula. Substitute the value and use e to the power a plus b formula. It can be written as e to the power a into e to the power b. Before that, divide this 1.82 to these two terms, and it is being integrated with respect to y, so that x terms are constant. Take them outside. Only thing is this is remaining. Use a change of variable concept. Replace these two terms by u square by 2. Take square root on both sides. U by root 2 is equals to this term. So this dy should be written in terms of du, so that differentiate with respect to y we get. As a result, this dy can be replaced by 1.82 divided 2 under square root into du. Finally, after a change of variable concept, this equation can be replaced with this expression. For this expression, let us make use of a definition of a gamma function concept. We know a definition of a gamma function. We do find such gamma function in our expression. We can observe here. These two are one and the same. So this term can be replaced by square root of 2 pi. Do the simplification properly. So 0.91 divided by 1.82 is 0.5. 0.5 can be written as 1 by 2. So after simplification, root 2 are cancelled. Root pi divided by pi is what? Root pi. 1 square root of 1.82 divided by 1.9079 is 0.7071. 1 divided by 7.071 is square root of 2. Alright, fx of x is calculated. Fx of x is calculated. Now let us calculate fy of y. Do some adjustment to this equation using a technique of completing the square. let us divide let us add and subtract 0.09 y square now, because we are finding fy. Added and subtracted. Let us make use of a minus b whole square formula, and first three terms can be written a minus b format. So the given bivariate PDF can also be written in this format. So we have calculated fx of x. Now we need to calculate fy of y, so that integrate this bivariate PDF with respect to x. All right. Substitute that fy of y. So substitute that bivariate PDF. Separate the terms. It acts as a constant because it is being integrated with respect to x, so that change of variable concept. Substitute these two variables as u square by 2. Take square root on both sides. This dx should be replaced in terms of y, replaced in terms of u, so that differentiate this term with respect to x here. It is not a y, it is with respect to x. As a result, this dx can be replaced by 1.82 under square root into du. As a result, they are constant written as it is. Dx is replaced by this equation, and these two terms are replaced by u square by 2. Using the definition of a gamma function, we do find one such gamma function in the expression. These two are one another same, so that can be replaced by square root of 2 pi. Do the simplification, we do get fy of y. All right. So for a given bivariate PDF, we have calculated fx of x and fy of y. Follow the procedures properly. Next question is volume of the PDF curve 1? We know the property of bivariate PDF, volume under the curve is always 1. To satisfy this equation, either make use of fx of x or fy of y, integrate it over the range minus infinity to plus infinity. If it equals to 1, then you can say that the volume under the curve is 1. Let us consider fx of x. All right, 1 by 2 phi square root of 2 pi is constant taken outside, so it is a gamma function here. So that can be replaced by square root of 2 pi. These two are cancelled, we'll get a 1. This result is 1, so that you can say that yes, the volume under the PDF curve is 1. That is the conclusion. Are x and y independent? To say that they are independent each other, this condition should be holds good. A bivariate PDF should be equals to multiplication of individual PDFs. We have the bivariate PDF is given, fx of x and fy of r calculated. If these two are multiplied, results 1 by 2 pi exponential of this term, but it is not equals to given a bivariate PDF. So that we can conclude x and y are not independent. They are dependent each other. Let us take one more assignment problem. 1 by 1.7321 pi exponential of minus s square plus 1.0 x square plus y square divided by 1.5, where x and y's are varying from minus infinity to plus infinity. Find fx of x, fy of y. Is volume under the PDF surface 1? Are x and y independent? So solve it by your own. Follow the same procedures. Write it in assignment book. If you have any doubts, means feel free to ask me. And if you want to discuss with me regarding your doubts, means you can make use of a comment box in the videos. And in the next class, we do start the next concept, that is expectations of bivariate random variables. So Don't forget to like, share, comment on the video, and subscribe the channel. We see in the next video. Thank you.